From Microbe TV, this is TWiP, This Week in Parasitism, episode 168, recorded on March 26th, 2019. I'm Vincent Racaniello, and joining me today here in New York City is Dickson Despommier.
Hello there, Vincent.
And from a remote location, Daniel Griffin.
Hello, everybody.
Hello, Daniel.
It's a nice day out, isn't it?
It's very lovely. It's a typical spring day for the change.
It's bright. I like bright.
I do too. And the tulip, no, not tulips, the crocuses and the daffodils have thrown up their leaves, but they haven't thrown out their flowers yet. So it's all about to happen.
Things are sprouting.
It's all about to happen. You see the red buds are out.
I was going to say I'm cold. I just got back from Panama where it was really the appropriate temperature.
Yeah, well.
Now it's chilly.
Panama. How was Panama?
Panama? Panama was fantastic. And one of the things a bunch of us that have been going for several years commented about is that we were not seeing as many different cases, I think, as we used to see, or the severity. So we always get a little bit negative at times about neglected diseases and neglected peoples. But it's really heartwarming to see that the efforts of this organization, the Floating Doctors, over the last decade has truly made a difference that is visible. So it's really positive.
It's great.
Good news.
Well, you would know. You're there in the trenches, as they say.
Oh, so it was great. Great to see.
All right.
How was the weather, by the way?
So the weather, this is the rainy season. It's interesting. Panama City and then the Bocas del Toro archipelago have kind of inverse weather. So this is the great time to go to Panama City. It was sunny and beautiful when I was there. But we had rain most days when I was up in the archipelago, but still spectacular.
Right.
Dickson, have you been to Panama?
Almost. My wife and I were on vacation in Costa Rica, and we made a driving error and almost had to go through customs. We turned around at the last minute, but
quite a driving error.
Well, not really. There's a lot of back roads out there, and we didn't know where we were, and we were having fun, just driving around. But all of a sudden, it says Panama border 10 miles or something like that. And, oh my God!
Is that where you used to go flat fishing?
No, Andros. I used to go to the Bahamas.
Oh, that's Bahamas.
But Costa Rica is a great place to fish also, by the way.
Yeah.
It's wonderful. Yeah, all of the coastline of Central America is fantastic.
All right, let's get to our case from the last TWiP. Daniel, remind us what we have here.
Yes, for those clicking or tuning back in, those clicking or tuning in for the first time, we discussed the case of a woman about 30 years old who had traveled to the Dominican Republic, Punta Cana, which is the tourist part. And she had returned, went in for a yearly physical, and her primary care doc had asked about her chronic constipation. And she thought about it, and she had said, you know what? I've been having normal bowel movements. Everything seems good. My chronic constipation that has plagued me is gone. So the primary care doctor was a little bit intrigued, asked a little bit, and then that was where there was this association to the travel to the Dominican Republic was noted. And she said, it was actually after I got back from my trip to the Dominican Republic that I noticed that my bowels were now fine. The primary care doc sent off some tests, and we have a report of entamoeba hartmanni in the stool, ova, and parasite exam. And then we left our listeners with a bunch of questions. What might the doc have done? What might have the response been to this finding? And what might have been the consequences of different responses to this
Indeed.
Response of the PMD, let us say.
PMD, that's right.
Daniel,
primary medical doctor.
Daniel, since the last time I visited the clinical laboratory here at Columbia, I was given a tour by the assistant director.
Oh, yeah.
They showed me the parasitology room, which was a tiny room off to the side. And he said they do everything by PCR. No O&Ps anymore. I said,
Right.
well, of course, if you're in a resource challenged area, you say, oh, well, of course, yes, but we are not resource challenged.
No, far from it.
But it made me think of our O&Ps all the time. They had pictures of eggs stuck up on the wall, Dickson.
Yeah. No, I used to communicate with that place quite often when I taught.
Yeah, they asked about you.
Mm-hmm. Did you tell them I was still alive?
Yes, and yeah, for sure. You should
Excellent.
go over sometime and say hello.
Oh, I ran across Miguel Guelpi, who was the chief parasitology diagnostician for many, many years, and he's often seen in the streets, walking between his house and the lab.
Mm-hmm.
He's retired also. He's a nice man, a very, very competent microscopist. Wonderful to talk with.
Yeah, they had a few microscopes. They had a hood.
Yeah.
They had some PCR machines.
Right. In case the electricity goes down, you can still, that would still not work though. You still need electricity for the light, for the microscope.
I have to tell you, the equipment in the microbiology lab was amazing.
Yeah. It's
Huge. Daniel, I'm sure you know this. They have a huge Roche machine, which took up half the room just for measuring HIV loads.
Wow.
Yes. Yeah.
Unbelievable.
Wow.
And they all have these huge power backups in case the power goes.
Wow.
Unbelievable.
Wow.
All right. Dixon, would you
Yes.
take
Sure.
the first one, please?
So Chelsea writes, hi, enclosed is my response to the question posed. 1, what should the PCP do? 2, what might have happened? 3, what are the consequences of the disease and treatment? My last helpful textbook was Clinical Microbiology Made Ridiculously Simple a million years ago, so bear with me here. The CDC, as well as various assorted sources, say that Entamoeba hartmanni is non-pathogenic. It's a commensal organism that does not require treatment. It used to be referred to as the small race or minutia, as it looked very similar to Entamoeba histolytica, but it is a lot smaller. Transmission is via cysts in the stool, so she's likely contracted it through contaminated food, water, or fomites. Versus histolytica, it seems to be called non-pathogenic because it doesn't invade surrounding structures. 1. In terms of what you should do, my educated guess would be nothing, but maintain good hand hygiene. It's not supposed to be harmful to the host. 2. For what might have happened, the primary care physician, or PCP, could have easily prescribed metronidazole, iodoquinol, or chloroquine. All of these are treatments for intestinal amoebiasis. 3. Side effects of all of them are diarrhea. More serious potential side effects for metronidazole would be aseptic meningitis and optic neuropathy, which are associated with higher doses of the drug. For iodoquinol, it can cause alterations in the thyroid gland function and is also associated with optic neuritis. For chloroquine, retinal damage. I have no idea why the amoebiasis is helping her with her chronic constipation, as it shouldn't be doing anything to the intestinal wall. As far as I could find out, it doesn't really have an interaction with it like histolytica does. So perhaps there was a diagnostic error, as hartmanni and histolytica are morphologically similar, and a PCR test might be needed if this was diagnosed only by microscopy. So maybe she does have histolytica, and the damage to the intestinal wall is helping with her constipation, as she would ordinarily have diarrhea with blood and mucus instead. So I wonder what exactly is the quality of her new normal stools. Some people are asymptomatic, but otherwise invasion of the intestinal wall can cause a perforation and peritonitis. Toxic megacolon is also possible and has a high mortality. Granulation tissue can occur at the sites of healing amoebic ulcers and cause an intestinal mass called an amoeboma. Fibrosis can also cause intestinal stricture. Histolytica then can invade distant sites, the most common being the liver, and the subsequent necrosis of that site can cause an amoebic abscess. Rupture of the liver abscess and erosion to the diaphragm can lead to pleural effusion and pleural abscess. You can have a pericardial amoebiasis with clinical signs of pericarditis and congestive heart failure. Tamponade physiology and shock can also occur. Cerebral amoebiasis is particularly bad. This answer turned out to be a lot longer than expected. I'm a long-time lurker, first-time answerer. I hope it was a good try. I'd love to be in the running for your book. Still snowing in Rochester, New York. Chelsea. P.S. How did you guys decide on getting Ronald Jenkins? Love that guy's music, but did not expect to hear him composing your intro music. Then she gives a reference to Hunter's Tropical Medicine and Emerging Infectious Diseases, 9th edition. Some Googling.
Well, Chelsea, years ago when we started TWiP, I was looking for intro music, and my son, my older son, was a big Ronald Jenkins fan. And so I'd heard it around the house a lot. And he said, you should use Ronald Jenkins. And I said, sure. So both the intro and the outro are Ronald's. And I have told him about it, and he thinks it's really cool. I got his permission to use it. And we use it on some other shows, TWiM and TWiV as well. I've used it for my videos. I really like his music. So we're cool here at TWiP.
Is he still producing new pieces?
Yes, he is.
Ah.
Sure. In fact, even Urban Ag, we put one of his pieces on Urban.
Do you upgrade the Jenkins music as he upgrades?
No, I don't change it. I don't change it, no. But when we make new shows, I use new music or new videos. For example, let me give you one brief example.
Would you please?
Right now I'm teaching virology and I'm recording my lectures, and I put them on YouTube every year. And every year I use new introductory music so that you can just distinguish them.
That's
and
very
this
smart.
year
very
I put a little thing from a new Ronald Jenkins
Is
song.
that because your old lectures are just like your new lectures?
No, they're not.
That was
They're
just
different.
a joke. It was just a joke.
They're different.
Sorry.
It's okay. I'm not offended. It's one of the few things that gives me joy, including podcasting, lecturing. It gives me great joy.
It shows in your face.
Sitting in traffic does not give me great joy.
No.
Daniel, can you take the next one, please?
Sure. I was going to say I appreciate the fact that the theme music is a constant in our world, so hopefully continue. Nathan writes, "Hi, TWiP experts. At first, when I hear Punta Cana, I immediately thought of the 2 tourists that were infected with hookworm last year when walking barefoot on the beach. But this case doesn't sound so easy. I started by listing the notes that Dr. Griffin provided. 1, travel to Punta Cana. 2, resolution of chronic constipation after a few weeks. 3, Entamoeba hartmanni isolated. Several Caribbean parasites initially come to mind, including Schistosoma mansoni, Strongyloides stercoraceous, hookworm, and the usual intestinal suspects, Giardia, etc. Entamoeba hartmanni is typically non-pathogenic in healthy people, so I found it odd that this was the only parasite that was isolated. As for the resolution of the constipation, I didn't and still don't have a good explanation. I found an article published in Frontiers of Cellular Neuroscience titled Gastrointestinal Parasites and the Neural Control of Gut Functions that discusses the impact of some parasitic infections have on gut motility. Perhaps this woman's parasitic infection has improved her gut motility and this has temporarily resolved her chronic constipation. I think it would be beneficial for the doctor to ask the patient to submit a second sample. It is possible that a pathogenic organism was missed. Intestinal non-pathogens sometimes keep the pathogenic organisms company. I noticed that the resolution of the constipation began after a few weeks, which makes me lean towards some kind of soil-transmitted helminth rather than an amoeba. If this is the case and the patient is infected with something like Strongyloides stercoraceous, the constipation will likely return in addition to nutrient absorption complications. I'm looking forward to hearing the rest of this case on the next episode.
The next is from Benjamin, who writes, "Dear Giardians of the Galaxy."
Fantastic.
I love it.
Awesome.
I love this case because it reminds me of the numerous stories I've heard of people waking up one day having overcome problems they've had in the past with no obvious reason why, myself included. I don't have a great deal of medical knowledge, but I'll do my best to propose some ideas. 1, E. hartmanni is pretty well ubiquitously considered a commensal that is incapable of causing disease, but I found a very recent paper that suggests it may be associated with chronic mild diarrhea. It provides a link. Perhaps the combination of pre-existing constipation and something that causes chronic mild diarrhea leaves the patient with regular bowel movements. If this is the case, I would suggest no treatment unless the diarrhea becomes a bigger issue than the constipation was. I like this idea most because I think there are a huge number of pathogens that cause common or complex symptoms whose disease burden we either underappreciate or is currently undiscovered, and recognition of this puts us a step closer to helping the people affected by them. 2, E. hartmanni apparently looks very similar to E. histolytica. Perhaps this is causing a similar situation to what I described above, but was misdiagnosed. This seems unlikely because she has no described symptoms that it would fit E-histolytical, and I assume in the USA this would not be diagnosed by stool microscopy because of the other potentially confounding amoebae. 3, the diagnosis has nothing to do with the resolution of her constipation, but is simply a coincidence. It isn't clear whether she was previously infected with E. hartmanni, and given that it is common pretty much worldwide according to my brief reading, I don't think we can be overly confident that she acquired it in the DR. 4, and most likely, it's something completely different that I haven't thought of. Something I read while looking through the E. hartmanni literature was the extreme prevalence of parasitic and neglected diseases in Australian Aboriginal children. I also heard a presentation once that said remote Australian Aboriginals are the population with the world's highest rates of trachoma. While this both shocks and saddens me, it reminds me of a discussion on TWiP many moons ago with Peter Hotez, where he discussed the underappreciated burden of NTDs among the poor in rich countries. Perhaps this topic deserves revisiting. Is the prevalence of NTDs in richer countries better studied, appreciated, or understood than it was in 2011? I would love to hear what the TWiP team have to say about this. It's the first day of autumn here in sometimes too sunny Adelaide, South Australia. I put autumn in inverted commas because it is currently 40 degrees Celsius, and I don't think that fits anybody's idea of an autumn day.
No.
Thank you all for the wonderful work.
Could fry an egg on it.
Keep calm and TWiP on.
Great.
Ben, an opener and a closer. That's great.
Yep. And the next one's not so bad either.
We should have Peter Hotez back to talk about the current state of NTDs.
He would be happy to, I think.
Ben is a PhD candidate in a malaria lab at the University of Adelaide. Would you say it Adelaide?
They would.
And what would you say?
Adelaide.
Adelaide?
Yeah.
All right.
Actually, I've been to Adelaide. Adelaide's a lovely city, by the way. It's just it's at the mouth of the Murray River. It's
all
quite
right.
beautiful.
Tell me north, south, east, west.
It's on the south coast west of Melbourne.
West of Melbourne?
Well, west of Melbourne.
Like what, 8 hours west?
Maybe 6 hours driving. It's in the Grampians. It's near the Grampian Mountains.
I don't have a Grampy.
The Grampian, whatever.
You can take the next one.
Thank you. Carrie writes, Dear Twipson.
That's great, too. I like that. I got that one.
Yeah, I love it. You've given us quite a hard one to make up for the previous 2 softballs. That's not a complaint. It's fun to have something you can really sink your teeth into. This case is made even more difficult by the fact that we don't know what caused the chronic constipation, let alone cured it. Perhaps the condition that causes constipation and some parasites that cause loose stools are balancing out somehow, leading to normal seeming bowel movements. Or was the condition actually corrected by whatever happened in the Dominican? Given the lack of solid information, we are making a tree of several possibilities. A. The softer stools are caused by E. hartmanni. B. The softer stools are not caused by E. hartmanni, but are caused by something she acquired at the same time in the same way, probably in the water, making E. hartmanni an indicator of sorts. Small 1. They are caused by a eukaryotic parasite. Small II. They are caused by something other than a eukaryotic parasite. And then back to C. The softer stools are caused by something completely unrelated, and the E. hartmanni is a red herring. And then she said, see above for all these other things. She's very indexing prone. We are mainly considering organisms which cause loose stools / diarrhea on the grounds that this patient has what are loose stools by her standards. Possibly A has some merit. Many organisms cause no symptoms in the vast majority of the population, but in a few rare patients do cause GI symptoms. Given that this patient has a history of GI trouble, she may be at risk for membership in that group. While cursory searches on the internet and in parasitic diseases reveals no instances of diarrheal disease or even softened stools caused by E. hartmanni, that doesn't mean it's impossible. There is infinite variation in biology after all. If indeed this is the case, there is probably no reason to treat the patient at all. The organism is causing no apparent harm and is in fact beneficial, though of course the situation should be monitored. Possibility B. Other waterborne parasites bring up several options and the same objection to most of them. There are numerous diarrhea-causing parasites in the water in the Dominican Republic. However, her stool was examined and one protist was spotted. Most of these other options should have been spotted as well. There is a laundry list of protozoans which cause diarrhea or can cause diarrhea under some circumstances. Cystoisospora belli, Cyclospora cayetanensis, Blastocystis hominis, Dientamoeba fragilis, Balantidium coli, and last, TWiP's villain, Giardia lamblia. There is fairly little to choose between most of these, and if indeed any of these are causing the patient's symptoms, it is fairly atypical presentation. We can probably eliminate Giardia, though not only was it the solution last time, but it has very distinct symptoms that are not present in this patient. This is disappointing, as it is a classically hard to spot in a stool sample. Going through those above, Cystoisospora belli causes secretory diarrhea, in other words, water loss from the lower intestine. This could theoretically be loosened in the patient's stools if her constipation was caused by dehydration. However, there are two big objections. The patient has suffered from constipation for years, and if it were merely dehydration causing it, there are several products that can help draw water from the intestines and soften the stools, and she probably would have tried these. Secondly, she is probably not immunocompromised, and C. belli mainly infects the immunocompromised. Cyclospora cayetanensis, most likely the same as above. While an immunocompetent person may catch this, it will probably clear up quickly, making it less likely to cause symptoms for so long, we assume several weeks at least. Blastocystis hominis is very common worldwide and is usually not pathogenic or not unambiguously so. It can cause GI symptoms, but it isn't associated with immunocompromised patients in particular and is generally very mysterious. That at least fits with this case. Dientamoeba fragilis also causes diarrhea, sometimes in some patients, and like B. hominis, it isn't always clear where, when, and why. As an added bonus, it's hard to detect being fragile, which would explain that bit at least. Balantidium coli is known to cause chronic infection, which fits with this case. However, it causes dysentery, which doesn't. It also tends to cause much more severe disease. And finally, a tinfoil hat option. She actually has E. histolytica, not E. hartmanni. While the story normally goes that E. hartmanni is confused for E. histolytica by an inexperienced diagnostician, leading to unnecessary treatment, it could theoretically happen the other way around. However, that is unlikely for many reasons. For one, the examiner should be looking for the disease-causing organisms and would have it on their mind. It would be truly spectacular incompetence to brush off the harmful amoeba as the morphologically similar harmless one. Furthermore, E. histolytica causes dysentery, which was not noticed in this case. The treatments for these protozoans are quite different, so further diagnostics are needed. Since examining the stool didn't detect any of these, we would use PCR. Next, we go to possibility B, number 2, a waterborne pathogen that is not a eukaryotic parasite. The main cause of a traveler's diarrhea is E. coli, and there are plenty of other bacteria as well. However, we would not expect these to last so long at equilibrium, especially after coming back. Another option, her constipation was caused by some irregularity in her gut flora. In that case, this patient unwittingly drank contaminated water, and by sheer fluke, instead of picking up any of these many nasty beasties that are transmissible by that route, she got a commensal amoeba and some of the normal gut flora that she was chronically lacking. That would be the case for TWiM, but since this is a eukaryotic involved, perhaps Daniel was just feeling more evil than usual. It makes a good story, but it's not likely. Not really. Aside from the low probability, adults don't really add to their gut flora in the long term. Newcomers, are usually only present transiently before dying off or being killed off by the immune system. Next, we move on to the possibility C, one completely unrelated parasite. The patient was in the Dominican Republic, and there are GI symptoms, if you can call them symptoms. Strongyloides has to be on the list. However, it's very, very unlikely to be asymptomatic except for correcting constipation. And if the diagnostician noticed that E. hartmanni didn't notice this, they are even more incompetent than in the E. histolytica hypothesis. There are plenty of other helminths that can cause diarrhea, and many are in the Dominican Republic. Some examples: Trichinella, no. Hookworm, no, just no. Trichinella, hi Dickson, no, this is not this either. These all cause many symptoms, usually much more obvious than the very slightly loose stools, who would have been spotted in the stool exam, and the whole thing is altogether too far-fetched. However, it is known that some helminth infections can cure certain kinds of autoimmune diseases, including some forms of inflammatory bowel syndrome. In fact, as discussed in several TWiP episodes, some sufferers will even intentionally infect themselves with helminths. Could that have been the cause of her chronic constipation? Could she have acquired a helminth in the Dominican Republic and unintentionally given herself the same treatment? It's an intriguing possibility. However, the objection that a helminth should have been diagnosed by the stool exam still stands. Finally, we get to possibility C2, which translates to, we throw up our hands. Could she have radically changed her diet after the Dominican trip? Could it be psychosomatic? Surely you wouldn't do that to us. At this point, we stop. This is getting quite silly. We apologize for the enormous wall of text, but you rather asked for it with that bizarre and intriguing case. We don't really have a solution. Caitlin's gut instinct, no pun intended, is Blastocystis hominis. Carrie, who would have made that pun intentionally if Caitlin hadn't got there first, would really love the accidental fecal bacterial therapy to be true, but is going to go with the Hartmanni actually causing this as being slightly less improbable. This letter is a product of the notorious transatlantic duo Carrie from Newcastle upon Tyne, England, and Caitlin in Seattle. We can't agree on which one of us gets the book if we win, so please rip it in half, a la King Solomon, and send one half to each of us. In the future, we'll each diagnose the cases that are in our own section.
Yeah.
That was a great letter. Thank you.
I thought one of them was in New Zealand.
Well, maybe she's relocated.
Daniel, take the next one, please.
Yeah, I think they've been moving around a little bit. Chris writes, Dear Twipsters, temperature is back to freezing in Athens, Georgia, so it looks like we have a chance at another snowless winter. For this case, and depending on the ultimate diagnosis, the infection seems to be unusually fortuitous. My immediate thought is that infection normally associated with loose stools might have brought some regularity to the patient, however precarious that balance might be. Since E. hartmanni is usually non-pathogenic, the intestinal changes experienced by the patient are very possibly unrelated. This amoeba may only be an indicator that she has been exposed to fecally contaminated food or water, and she should be retested for parasites that might have been missed, including Giardia and Cryptosporidium. Another possibility is strongyloides, which develops quickly enough to induce intestinal changes in the time frame seen here, and frequently evades detection on fecal exam. In this case, the physician may order a serological test. In any event, a follow-up fecal exam may reveal parasites that are already affecting the gut, but haven't yet reached patency. Best, Chris.
Patency. What does that mean?
Means
Tell us, Dickson.
Detectability. It produces a stage in its life cycle, which can then be detected on stool exam.
Okay, Kevin writes.
Oh boy, he writes very small.
Kleptoparasitism and the stercoraceous souvenir, a.k.a. the Colonic Stowaway from Hispaniola. Wow. This 30-year-old woman trip to DR. Patient's history of constipation present since childhood has resolved upon return. Routine wellness visit seemed to stimulate a thought which resulted in a lab finding of E. hartmanni. The provenance of this eponymous amoeba is traced in the endnotes. Is this physician engaging in fecal relativism, where a restoration to, quote, normal in a chronically constipated patient is interpreted as a diarrheal equivalent? I admit that the logic of this possibility could be described as tortured. Nevertheless, this story is a reassuring counterpart to the standard narrative of cruise ship diarrhea and the dreaded Turista or Montezuma's revenge. If anyone even uses these questionable expressions anymore, our case is a very arresting anecdote. It holds promise. It has the allure of tropical travel, leisure, and an intimate, if not occult, association resulting in an unexpected resolution of a disturbing condition by a lowly actor formerly considered a parasite.
You know, Vincent, I think we should serialize this letter and just dribble it out over the next 3 TWiPs because the writing is exquisite.
It's wonderful.
I love the writing.
Despite my aversion to medical metaphors, this case, with its tantalizing vagueness, has spawned a cascade of topics that can be best described as constipating the mind. The historical sweep of our case encompasses protozoology's golden age starring Hartmann, Schaudin, and Giemsa, as well as the frontiers of the gut microbiome, We may also mention so-called late capitalism, wherein previously valueless human feces has become commodified. See Sunday, March 3rd, New York Times feature on fecal transplantation.
Love it.
The New York Times account of a fecal transplant imbroglio recalls Part 3, Chapter 5 of Gulliver's Travels, The Voyage to Laputa. The most ancient student of the Academy, his employment was an operation to reduce human excrement to its original food by separating the several parts, removing the tincture which it receives from the gall, making the odor exhale, and scumming off the saliva. He had a weekly allowance from the society of a vessel filled with human ordure about the bigness of a Bristol barrel. The intersection of Bristol here and the Bristol stool form scale shall remain unremarked upon. One might say that our patient had an inadvertent microfecal transplant while traveling. Though Entamoeba hartmanni was recovered on return to the U.S., we do not know if she had this commensal in her gut prior to traveling. It's also unknown what other bacterial, fungal, or protozoan commensals she may have acquired during her trip. We simply have a seductive scenario of a person with a nettlesome chronic disease who has been apparently cured through travel, with the lowly E. hartmanni serving as a MacGuffin or red herring. There are some very large lacunae in this story, and making the assumption that E. hartmanni is the agent of her release is impermissible. Nevertheless, this parable...
My jaw just hit the table.
Nevertheless, this parable produces a good excuse to meditate on the gut microbiome. The bacterial gut microbiome has had a head start on the so-called eukaryome, some say eukaryotome, due in part to the earlier availability of 16SR RNA assays. Newer 18SR RNA assays and other techniques have begun to elucidate the fungi, protozoa, and helminths that live within us. Studies on commensal eukaryotes in the gut are at a very early stage, however. Classification of gut protozoa are being reassessed as to who is what: a parasite, a pathobiont, symbiont, commensal, mutualist, etc. Greater gut microbiome diversity is now believed to be beneficial. There is the hygiene hypothesis and the old friends hypothesis that postulate that the decline in microbial contact in infancy and childhood has led to the development of allergic and autoimmune diseases. The old nostalgie de la boue. I could find nothing in the medical literature to suggest that protozoa could be employed in the treatment of constipation, but a reference is included that claims that fecal transplantation was beneficial. Population surveys show relatively low levels of E. hartmanni colonization in the 3% range. There are a few case reports that try to tarnish the reputation of E. hartmanni by associating it with reactive arthritis or mild diarrhea. Regarding our patient, it is possible that her new old friends, E. hartmanni and possibly others, have had salutary effects on gut motility, mucus production, production of local neuroendocrine mediators, such as serotonin, gut immune, and inflammasome function. Something got things moving again. Leung reference has a poetic way of describing this whole situation. Quote, parasites can serve as an ecosystem engineer for gut microbes by altering the physical landscape in which they reside. Mm-hmm. I can only hope that our patient is not in a honeymoon period with her new companion and that there will be no return to costiveness. Also, there is perhaps a deeper meaning to the 70s expression, get your shit together, by appreciating our inner universe and the likely benefits of migrants, we might come to a greater understanding of biology and whatever other metaphor you like. Thanking TWiP triumvirs, or do you say triumviri?
That's on TWiP.
And then we have a copious number of endnotes, references, and a terminal curiosity, which I would encourage everyone to look at. They will be in the show notes, microbe.tv/TWiP, or you can find them in the letters read. And he goes through Entamoeba, entomology, Luminex technology.
Good Lord.
Throwing shade on hartmanni, the gut microbiome, gut protozoa. Are in human intestinal eukaryotes beneficial or commensals? This is all proliferately referenced. And constipation, fecal transplantation, the water fallacy, and miscellany. He defines constipation in 6 different points, including less than 3 bowel movements a week. Let's see what else here. Diet and lifestyle, management of constipation. Then he has a constipation score from a scoring system to simplify evaluation and management of constipated patients. You could have frequent, difficulty, completeness, pain, time, assistance, failure, history, etc. And then here is the terminal curiosities. I came across two martyred parasitologists while researching this TWiP episode, Proazek and Giardian.
Giardian, yes.
I believe that Dr. Despommier's 1995 book, Entamoeba histolytica, details the death of Giardian. Perhaps a new section of heroes and martyrs and maybe self-experimenters can be shoehorned in the meantime. So he talks about Hartman here, and its collaboration and so forth.
I'm reminded of Hunter, by the way. You know, the Hunterian Museum in London?
Yeah.
You know what he died from?
No.
He died from self-inflicted syphilis.
How do you do that?
He just wanted to find out what it was like.
Oh, my gosh.
Yeah.
Scatologic rights of all nations, a dissertation upon the employment of excrementitious remedial agents in religion, therapeutics, divination, witchcraft, love philters, etc. Wow, that's actually a book. Scatomancy, kleptoparasitic dung beetles as used in divination by the ancient Egyptians. This is where I learned the word kleptoparasitic. It is a super word. Wow. Sexually transmitted amoebiasis, and then a core agenda on the comment in TWiP 166 that Joseph Merrick, a.k.a. the Elephant Man, suffered from neurofibromatosis, though I generally detest historical medical speculation, e.g. Van Gogh had macular degeneration, King George had porphyria, etc. I am moved to comment R.E. the Elephant Man. In 1986, it was conjectured that he had Proteus syndrome. DNA tests on his hair and bones in 2003 were inconclusive, and he gives a reference for that. Okay. Phew.
Woof.
Dickson, I think you're next, but I've forgotten.
I think we should encourage him to publish all of this so that we can have all of his comments together in a single place.
Yeah, we could do that.
He's a remarkable scholar.
By the way, he has sent a hero as a proposition.
Saw that.
And he's willing to flesh it out for you.
You didn't really mean that, did you?
It's a mistake.
That's true.
I think you're next.
Freudian mistake. Blair writes, "Dear all."
Where'd you get
Cecilia?
Blair? Cecilia.
You skipped Cecilia.
Did I?
Yeah.
Go up just one.
Oh, I'm so sorry. I beg your pardon. Cecilia writes, "Dear doctors, when I heard the case of the 30-year-old woman with Entamoeba hartmanni, I was reminded of the difficulty in distinguishing Entamoeba hartmanni from dwarf forms of Entamoeba histolytica. There are some clear differences in the appearance of the peripheral chromatin in the nucleus as well as the appearance of the karyosome, but careful examination of properly stained smears must be done to distinguish the two. There's also an overlap in the size of the cyst stage of E. hartmanni and dwarf histolytica. Since the lady in question had no symptoms, in quotes, except for normal bowel habits after having problems with constipation, maybe she has a mild form of Entamoeba histolytica infection, and the organism was erroneously called Entamoeba hartmanni. The literature does not say that only some people infected with the histolytica develop amoebic dysentery. There are other differences in the cyst and trophozoid forms of these organisms, but they require a properly stained smear of the concentrated specimen. Also, Entamoeba histolytica and Giardia are the most common parasites acquired in the Dominican Republic. I hope I'm not offending anyone by the above observation. Being a laboratory scientist, I understand the difficulties of performing these tests. Thanks very much for sharing your knowledge with your listeners. I have learned so much from you. Sincerely, Cecilia from St. Petersburg, Florida. P.S. My husband just returned from a yearly medical mission trip to the DR. I must say that this kind of case, if I can interject here rather than waiting later, this caused the entire laboratory that I trained in here at Columbia to drop what they were doing and go over and look at the microscopy specimen under observation by a single technician. We had 6 people in the lab, and 5 of us were then marched past that microscope, and we weren't told what it was. They just said, "What do you think I'm looking at?" And each one of us had to speculate as to what that was.
That's nice. That's very good.
Yeah, and it was really well done. And Dr. Harold Brown was a genius at presenting these in situ cases, so to speak, so that his technicians remained as sharp as they could possibly be.
Including you.
Well, I tried. Let's put it this way. You knew that patients' lives were at stake sometimes.
Yeah, of course. All right, Daniel.
I will read Blair.
Sorry,
Blair
I
writes,
didn't mean to step on your lines.
That's okay. Blair writes, Dear all, delighted to have won the book from TWiP 166.
Nice.
As for the case from the latest podcast, Entamoeba hartmanni is a non-pathogenic colonic protozoan. It is a reflection that an individual has ingested contaminated water or food or has suboptimal hygiene practices. Found on its own in an asymptomatic patient requires no intervention, and if found in a patient with diarrhea, should prompt further investigations to search for a pathogenic organism that has been overlooked. There are lots of other non-pathogenic gut protozoa, which often get picked up on in stools, and our tropical advice service frequently gets contacted to ask if treatment is required for a number of organisms. A non-exhaustive list includes Entamoeba coli, Dispar, Moskovsky, Endolimex nana, Iotamoeba buchley. The primary care physician may or may not have offered treatment with metronidazole, but reassurance would be all that was necessary. I am wondering if her time spent in Dominican Republic led to a change in gut flora and a resulting shorter transit time. From a brief search of the literature, it seems that gut microbiota plays an important but as yet not fully elucidated role in intestinal motility, and that you can slow gut transit time by transplanting the gut microbiota from individuals with constipation into mice. 2, fecal microbiota transplantation has already shown its utility in the treatment of refractory C. difficile infection, so maybe it can be a cure for constipation as well as diarrhea in the future. The gut microbiome is a fascinating subject that I believe we're only just beginning to gain an understanding of. Additionally, thank you, Dickson, for sharing your trials and tribulations of long-distance air travel. I do find it to have the same effect.
Right.
Is that bringing back flashbacks for me that I hope to leave.
Right.
Best wishes, Blair. And she gives us a few references there.
Yep.
All right, that's it. It's our guesses. Pretty impressive.
Very impressive. We got a lot of really sharp, interested listeners.
I like the idea of the microbiome change, and that this thing is a red zebra.
You heard the hooves, and it was a red zebra.
Okay, Daniel, take it away.
Well, I this is the part where you and Dickson get to tell me
That's
what
right.
your thoughts are.
Exactly.
Right? So we had this case, and you, I'll let you guys jump in. So what I guess the first, Vincent, you sort of jumped in there.
I
Yep.
think that she had a microbiome shift, which is known when you travel. We do know this. When you change food, your microbiome changes. And I think in her case, it affected her gut motility. And I think the E. hartmanni is there, and it's not pathogenic, and it's not doing anything. It was a little bit of a distraction. What do you think, Dickson?
Well, no, I think I want to fine-tune your diagnosis, because I think E. hartmanni is a indicator species.
Indicator of contaminated
Correct.
water or something?
Yeah, of fecal contamination. There's only one way to catch it.
Maybe that's how she got her microbiome transplant.
I would assume that's exactly right. So that is, I concur entirely with your diagnosis, doctor, that this patient has had a change of gut flora, perhaps traveler's diarrhea, which in her case is traveler's normal, because she was already suffering from constipation. So if you've got traveler's diarrhea with a new strain of E. coli, for instance, which is typical, then her bowel movements would change tremendously as a result of that. And it was associated with ingestion of feces from a local person that lives in the Dominican Republic. And so I would flesh out the scenario in that direction and say that because E. hartmanni was the indicator species for fecal contamination, and we didn't find any other eukaryotes, then I wonder if you could actually tease out the new microbiome additions by some culture technologies. I don't know, but that's what I say. Daniel, we didn't ask you whether there were any other tests or follow-ups or, times 3 or times 10 stools to see if there was anything else there. assuming that there was no other addition to the diagnosis. But
now you guys get a little more information. I felt like this would get a little too complicated if I threw it out, but we're going to see what your guys' response is. So why did they send this person to me, right? This person goes and is seen. So it actually, many months, this woman is going along. She's doing, from her perspective, great. She's delighted that her chronic constipation that's plagued her is gone. She sees her primary care doc, who identifies this and says, you know what? You got amoeba and your stool here. I'm going to give you a week of metronidazole.
Here.
Okay, so
she gets her cocktail parties.
So she gets her week of metronidazole, and apparently she didn't drink during that time, so it was not a problem. And then she actually has a stool out, test for cure, and this time it comes up negative. We don't see this again. But why is she sent to me? She's sent to me because now her chronic constipation is back.
But remember, metronidazole treats all anaerobes, not just eukaryotic anaerobes. It treats lots of other anaerobes too.
Okay.
So it could have knocked out the bacteria that were responsible for her transit time change. Possible.
Interesting.
But very interesting. I mean, very interesting.
Yeah, it is interesting. I mean, I will say, as Dickson brings up there, I think is a good point, is that, it would be wonderful if she had undergone, we'll say, Hartmanni phage therapy or something, where it just,
right. just hit that one.
just hit this one, removed it, and then we had this thing. But the metronidazole is, you call it flagell, right? Because it does target flagellates, but it also targets anaerobic bacteria. So it's not clear, right? We don't know the answer to this. Did it affect bacteria? Did it affect the amoeba? But it wouldn't affect E. coli. E. coli is not affected by that because it's not an anaerobe. So if the theories of now she has an enteroaggregative E. coli or some chronic E. coli thing, but it does raise a very interesting thing. And the reason she's coming to me is she's not happy. She was actually delighted to be. And so she wants to know, how do I get back to where I was? And she's very upset that she took her metronidazole for that week.
What was the name of that city she went to? I'd send her back.
Actually, that was actually my advice. I said, why don't you go visit again? And and don't, I think we had people talk about suboptimum hygiene, etc. I was like, whatever level of hygiene and adventurous eating that you were involved in last time, go for it. Next time, if you get all better, don't take the flagell.
Exactly. Gee whiz.
Wow.
That just Dominican Republicanized her. What a shame. I mean, it is a shame. It would have been a great story if the Hartmanni was gone, but she was still the same, and that would have been a wonderful outcome, but didn't happen.
Yeah, I mean, it's interesting because I think if I had gotten the call ahead of time, if I had gotten the call ahead of time, hey, I've got this woman and she's got this in her stool, and what should I do? I would have recommended against treatment. I would have said, you know what, that's right. Commensal. There's no indication for treatment.
Exactly.
But yeah, so it was really an interesting consult to get the woman who basically was saying, I so regret that I got this treatment because I was doing great for months. I got the treatment, and basically within a few days of finishing, I am back to my chronic constipation.
So here's another question that if I were this woman, I would then confront you with the following question. I said, well, okay, look, I've been doing some reading here, Dr. Griffin, and it turns out that fecal transplantation is fairly common right now for several disease entities. They're looking at this for malabsorption syndrome and things of this sort, or people who have been on acute antibiotic therapy and have had their whole microbiome wiped out, but they've saved it. They reinstitute it with a fecal transplant. How about a fecal transplant from somebody that's got a totally different set of microbial distributions for their microbiome as a way of trying to see whether or not you could affect the outcome in some non-invasive way?
Yeah, we're gonna be getting into our paper at a moment, but I am fascinated. I think, as a lot of our listeners probably are, with the growing understanding of the gut microbiome, macrobiome. I feel like we need a broader term because, as we're realizing, viruses, bacteria, maybe protozoans, other eukaryotic beings, creatures are in there. Part of something we evolved with.
The gut ecosystem.
I like that better. The gut ecosystem. And we clearly use this in Clostridium difficile treatment. And I actually have a colleague that I also sail with. I've sailed with a few times, Bruce Hirsch out here on Long Island. And he does quite a bit of the fecal transplant for Clostridium difficile, but he's made it a little more, I'm going to use the word palatable. Right, because the initial approach to this was they would put a tube up the rectum, and they would basically spray feces in there from another person. Then they came to the approach where they would put a tube in, from down your nose, mouth, and they would basically pour the feces into your top end. And then I worked with them a little bit on the idea of having a donor come in and you liquefy the stool with saline, but then you mix it 50-50 with glycerol, and you create these frozen feces pellets, tablets, actually. The person swallows like between 20 and 30 of them, and then they basically open up once they're into the top end there, and it prevents you from having to go through sort of the tubes. And the success is really high. I mean, 90% success in some of these recurrent C. diff cases where people are struggling. So I think there is an exciting future ahead of us in the whole gastrointestinal ecosystem.
So most of the water that's ingested from a normal meal or just during the day is absorbed through the large intestine?
It's an interesting issue. Our small intestine actually puts fluid in to the system, and then our colon is absorbing the fluid back out.
Right. So this woman appears to have an overactive absorption system. And it draws away too much water, and it leaves the stool overly formed.
Does that cause constipation?
Yeah, sure. Yes.
Besides transit time reduction.
Exactly.
Yeah, I would throw both in there because constipation can be caused from a lack of water, lack of moisture in the stool, or it can be caused by improper motility, sort of, basic big causes.
So you can explore each one of those separately by including some charcoal into the stool. Or into the food stuff. Into the food stuff they ingest. I've done these experiments in rats and mice because Trichinella causes an increase in transit time during some form of its life cycle. So you can actually measure how fast it got as a result of that. But that was a hypersecretory result of the small intestine. This is in the large intestine, right? So if she's not absorbing water at a normal rate, but at a hyper rate, which would leave the stool very, very dehydrated and not soft, then you can try to tease out which one of these two things is going on and then address that in some therapeutic way.
Now, is the result with the flagell, is that what you gave her?
So I didn't do it. Wasn't me.
All right. Well, is that
her primary care physician gave, and that would be a reasonable treatment for an amoebic infection, which unfortunately I don't think this was an infection.
So do we take from that there was some target of flagell involved in her?
I think the timing on both ends is very interesting. I mean, here's a woman who chronic constipation. Now, when she's got the E. hartmanni, she's doing great, whether it's E. hartmanni or that which travels with it. Now she gets medicine that targets E. hartmanni as well as anaerobic bacteria, and boom, she's back to the constipation. So there's sort of this compelling.
Got it.
Yeah.
All right. So what did you do with her? You just told her to go back.
I told her to go back. I said, go on another vacation.
Okay.
She's tried normal approaches like, taking prune juice or prunes or things like this.
So I'm going to jump in and call that an abnormal. Don't take prunes. So prunes are an irritant laxative. I think you brought this up last time. Yeah, they're an irritant. And so people that chronically take prunes actually can become dependent on them because you are stimulating bowel movements by irritating and which is is not a great thing to be doing to your colon. So I usually recommend exercise, increased fluid intake, and then maybe what we call osmotic laxatives. But stop putting irritants in your colon.
Yeah, so that's what you do, Dickson. You said when you travel, right?
I do. I take prunes with me, and I use them.
If you use them a few times, that's okay. But.
A few times, just a few. What about somebody who just likes to eat prunes? Are you recommending don't eat prunes?
Yeah, I'm saying just rein back the prune ingestion.
Forget prunes.
Well, you could have one here and there, but don't use it to cure constipation.
You should see the ads for prunes, and Daniel, you should actually watch a few of those ads. One of those ads shows a bunch of, I would say, late 30s, early 40s women sitting around having dinner or something like this, and one of them says, "Boy, I just discovered prunes. They're so delicious." And I know exactly what that was a code for. It was for this kind of a problem. And the others all agree with her, and they think prunes are fabulous. And so I think that's misinformation then, don't you?
It's interesting, and maybe our people will go and Google or search whatever they want. But no, actually in sort of the eating disorders and concerns about laxative abuse, there are warnings that hopefully people are getting about the long-term use of prunes, and prune juice can result in this issue. So be careful there. Be careful with your prunes.
I'll be, I love this program.
I want to point out I want to go back to Kevin's email and point out 2 points that he makes. First, The Scatologic Rights of All Nations is a book that you can download at archive.org. He provides a link. He writes, "This book is a must browse for anyone interested in all things fecal. I cannot recommend it enough."
Wow. All
right. And then he provides a link to Sexually Transmitted Amoebiasis. Yeah. And he says, for Dr. Racaniello, whose thorough clinical history always includes the important but delicate questions.
Hear, hear.
Case of 2 men who transmitted amoebiasis to each other, and they had genital ulcerations.
This is the finding that almost triggered the investigation for gay bowel disease, which they blamed on this organism, but it wasn't.
Yeah.
It was obviously the AIDS virus, but that's where that started. Very interesting.
Okay. Wonderful. Dickson.
Fabulous.
Daniel, thank you very much. Let's give away
our emailers. That was awesome.
Yeah, let's give away a book.
Wonderful. Now, how many guesses did
by the way, kleptoparasitism, he used the word.
Right.
Is a form of feeding in which one animal takes prey or other food that was caught, collected, or otherwise prepared by another animal. So if you've ever seen a seagull chase another and steal its food, that's kleptoparasitism.
Eagles are very famous for that.
All right, so
being the victims, right?
Yeah, exactly. Eagles are the victims. Normally they are the victims. That's correct.
All right, we're going to give away a book numbered between 1 and 5. We had 5 eligible listeners. Are you ready?
I've got the drum rolling.
Number 4, in my New Jersey accent.
You got it.
Number 4 is, let's see. Number 4 is...
Is that Cecilia or no?
It's before Kevin, I think. It's not Blair, because Blair won one last time. Boy, it's a long scroll, man.
It's our writer, our long writer.
Oh, yes. Yes, the duo who's going to rip Caitlin, Carrie. Caitlin. That's right. The winner.
Exactly.
And
right.
they want to rip it in half.
We said 2.
Let's. Yeah, would you please?
We can send 2. You want me to send 2?
Yeah, I want you to send 2. I couldn't bear to see this thing.
Carrie and Caitlin.
So guess what we're going to do? We're going to do a tricky little thing here, though. I suggest something here. We send both of the books to Seattle.
Yeah, I think that's good. It's cheaper that way.
Allow Carrie to get that book to her partner.
Yeah, so Carrie, Caitlin is in Seattle.
Caitlin,
send me your address, and I will ship them both to you, and you can figure out how to get it. You'll probably see Carrie at some point.
The next time you have a reunion, just slip the book under the table.
To send this book to the UK would be $90.
Exactly.
And that's expensive. And so
it is.
In fact, I'm delaying sending it to some overseas.
It exceeds the purchase price of the book.
Winners, because, yes, you could go buy it. We would reimburse you. But it wouldn't be autographed, right?
No, it wouldn't be autographed.
All right, we have a paper now which I picked in honor of Dickson.
That was very kind of you.
I did, because you don't often see a PNAS paper on Trichinella anymore, right?
Certainly never saw one of mine.
You never had a PNAS paper?
Let me think about that. I might have had one with some other people.
This is called infection by the parasitic helminth Trichinella spiralis activates a TAS2R-mediated signaling pathway in intestinal tuft cells.
Correct.
Are you going to get a hero?
Yeah, I have to get the book, though.
You can get up. It's just 4 feet away. Go ahead.
Understood.
This comes out of a variety of places in China and a place in Philadelphia, Pennsylvania. And the first author is Xiaoqi Luo, and the last author is Liquan Huang. And, I picked it because it's Trichinella, of course. But then I read it, and it turns out that there's another aspect of this paper which we are well familiar with here on TWiP and also on TWiV. The tuft cell, the intestinal epithelial cell, a rare cell called the tuft cell.
Indeed.
We talked about this on TWiV because it's a site of replication of noroviruses.
Yes.
And here on TWiP, episode 148, Weep and Sweep, how B1 cell IgE blocks parasite clearance by inhibiting mast cell activation by B2 cell IgE. And tuft cells were involved there.
I would say it's only rare unless there's something going on.
Remember that, Daniel? The tuft cell?
I do. I remember that well.
So these tuft cells are a link between viruses, protozoa, helminths, and alterations in the gut microflora. They get activated, right? Yes.
I was going to say, I'm going to get a T-shirt that says I'm a tuft guy, and then only about 6 people in the world will get the joke.
Yeah, you could have a picture of a tuft cell on it, yeah.
That's right. All my cells went to tufts.
So these cells get activated by signals from nematodes. We don't know what the signals are, and protozoans as well. A signaling cascade ensues, and IL-25 is released, which acts on intestinal type 2 innate lymphoid cells, which then secrete IL-13, which in turn directs stem and progenitor cells in the crypt to proliferate and differentiate into tuft and goblet cells.
That's incredible.
And that's like a Rube Goldberg series of things, right?
Seems that way.
And that leads to the weep and sweep response, including mucus secretion and the expulsion of parasites from your gut.
Exactly.
Out, damned spot. No, out, damned parasite, right? Right. So this paper is looking at the effect of Trichinella on tuft cells.
Right.
And what's happening and what's sensing them.
Exactly.
Right?
Exactly.
And the general approach is to take mussel larvae and give them to mice post-orally.
Which is the normal way of infecting.
What does it mean, normal, Dickson?
It means that this is an oral ingested parasite by nature.
Yes.
You ingest the meat with the larvae in it. You digest away the meat. You free the larvae up, and they start their life cycle.
So they use mussel larvae because that's what you would ingest.
And then they pepsin digest them artificially, release them, then you can count them, and then you can give a certain number to each animal.
I remember in your experiments, you used to inject these into the muscle to synchronize the infection.
Yeah, we did that with the newborns, but this is the larva that develops from the newborn in the muscle, in the nurse cell.
All right, so this is they want to know what the Trichinella does to the epithelium. Right. And is this something you looked at in your career?
I wasn't a gut, no, I'm serious. I knew somebody who devoted their entire lives to studying the alterations in gut tract motility and electrical potential and all that. His name was Gilbert Castro. He was at the University of Texas at Austin, and he did a fantastic job with it, but his equipment was really quite sophisticated.
So you were a muscle person.
I was a muscle person.
Interesting.
I was.
You can tell because you're just a very strong muscular.
I used to be.
So they feed mice, and then they look at and they see in the intestine, you can stain them, do sections and stain them, and you can see increases in the numbers of tuft and goblet cells.
Right. Huge changes.
And goblet cells make mucus, right?
They do.
Daniel, is there a disease where people lack goblet cells? Do you know of? That would be something, wouldn't it?
I don't know if there is a disease where you have a complete lack of goblet cell.
That would be something really bad, right?
It would be horrible.
Because they're not only in the gut, but you also have goblet cells. Think about when you cough stuff up, right?
Yep,
So,
sure, for sure.
Right.
And apparently there's also corneal goblet cells. So the goblet cell, as we say, it makes more than just mucus. Maybe that isn't an expression, but
Dickson, have you ever ridden the mucociliary elevator?
I've tried many times. I've pushed the wrong button each time. Went the wrong way.
So they want to know what is triggering this tuft cell proliferation.
Exactly.
And they believe, so this is very interesting. We talked about this on TWiP. Tuft cells have bitter taste receptors.
They do.
Why would you have taste receptors in your gut, Dickson? You said this on TWiP, remind me.
No, I don't. Well, you'll have to go back to that episode to find out.
All right.
No, but you should have mentioned that one of the authors is actually a faculty member here at Columbia.
Of this paper?
Michael Gershon.
Is it Gershon on here?
No, Gershon. No. I'm sorry. Gershon was on the paper that I sent as the review article.
As a review article.
What a tuft cell actually is.
Yeah, Michael Gershon is a professor here.
He is.
For many years, and his specialty was the gut.
The serotonergic nervous system of the gut.
That's right.
He championed that, as a matter of fact. So it's absolutely critical to find out what happens there, to know why these large parasites are taken care of, right? Because in the old days, they didn't think that there was any immunity at all developed against worms. Now, look how complicated it's become.
So they prepare mouse small intestinal villi.
Right.
Do you know how to do that? No, you weren't a gut person. Sorry.
No, that's not a difficult thing to do. You can make organoids from them.
Okay, so then they treat them with larvae of spiralis or adult worms and extracts, not just the whole larvae.
Right.
Extracts of larvae and adult worms. And then they measure IL-25 release.
Right.
And so both the extracts and they have a drug that stimulates these cells, increase IL-25.
Exactly.
And when they pre-treat the villi with an inhibitor of bitter taste receptors, they reduce the secretion of IL-25. How about that?
That's very interesting.
So they think there's this bitter taste receptor called TAS2R is the receptor for whatever it is that Trichinella is making. We don't know what it is, and we will not know today.
Maybe not even tomorrow.
Because they don't figure it out at all. It would be interesting to know, right, Dickson?
Well, that's what I did work on. I worked on the secretions of the parasite in the larval stage, not in the adult stage. But
you worked on secretions that cause angiogenesis.
I did.
And what did you find? What was the protein that does it?
We never got that far with it.
Does anyone work on it?
Not on that. I haven't run across much recent literature on that part of it. No.
So this is interesting. This compound that inhibits this TAS2R receptor, it's called allyl isothiocyanate. It's a component of mustard oil.
Huh.
Now, let me ask you, these bitter taste receptors in your gut, you don't feel the bitter taste in your gut at all, right?
No.
So what are they there for?
Because the serotonergic nervous system is not directly connected to the other nervous system.
Right. If it were, you might.
Yeah. I was gonna say, we think of it kind of from taste going down, but if you think about chemoreceptor cells developed probably, I'm going to postulate, before there was consciousness, before there was basically everything needs to go to a cognitive level. Sure. And I think that's what we're seeing. This is probably the source. So, I like to give the immune system lots of credit, but it's probably because our immune system needed the ability to sense things. Is we probably co-opted those to help us determine when we eat something. Is this something we should eat or not? And if you think about it, right, if you taste something and it's bitter, it raises a little, I'm not sure I should be eating this. Where if it's salty or sour or sweet, then we start thinking, this is probably. So it's interesting. I actually thought that it was the bitter receptor that is the one that is saying, ooh, Trichinella.
Yeah. You know what amazes me, this is an aside, but nonetheless relates to this very much so, that is the number of animals that are forced by scavenging habits to eat rotting carcasses. And the taste of that must be absolutely vile. And it doesn't seem to bother them at all, because maybe their hunger overrides the fact that they just are repulsed by it. But there is no repulsion effect in the animal kingdom for, let's say, a carcass of a gigantic whale that washes up on the beach. It becomes overridden with polar bears. They just go crazy over that. I've seen these nature specials of these, and the vultures, they stick their necks right down into the insides of the rotting carcass, and they come out and they're chatting with each other and playing cards and all that stuff.
Dogs will do the same thing.
I know that. So
just eat rotten stuff and not care.
the point is, we would never do that because our taste is up in our mouths, but maybe those animals only have taste buds down in their gut tracts.
No, I'm going to say I'm not sure. I think it's the opposite.
Because they won't eat certain things too. I mean, they're selective in their eating habits. There's no question about that.
Yeah, but I think I don't think they find it revolting. I think that the wiring is such that we are selected to be able to eat things that allow us to continue as a species. And I think, you walking down the beach with a dog and there's a dead animal and, the dog can't help but like roll in it, right?
It's true. You're absolutely right. You're right.
So it's not a revulsion. And actually, if you were an animal in these areas that could not eat and was not interested and willing to eat, let's say, a rotting walrus or a whale, it's not going to do well for you and your offspring in your genetic pool.
No, you're quite right. And continuing that thought, I think that if forced to eat rotting meat, we do. There are many situations of survival of people stranded in certain areas where they had to eat whatever was available, and they did.
I wouldn't eat rotten meat.
Well,
I'd bite someone's finger off.
There are some ingredients in food that if you only ate that ingredient, I don't think you could live on that alone. Like
you can live a long time without eating.
Thai fish.
You drink water, right?
Thai fish sauce. Have you ever smelled Thai fish sauce? It is a wonderful flavoring at a very small amount, but try to drink like a thimbleful just to drink that. It would, I think, just gross you out.
Look, I can eat pretty stinky cheese, but a lot of people can't.
You know what? That's an interesting fact, because you can smell something and it smells one way. When you taste it, it's actually completely different.
Oh, taste is a huge component of smell,
completely different. Yeah,
I've had colds where I can't smell and I can't taste anything.
That's terrible. I hate that.
Yeah, it was awful. All right, so the rest of the paper is involved at figuring out how the Trichinella extract does the cascade. I'm not particularly interested in it.
Well,
but I'm going to summarize it, and you guys can talk more about it. So they find basically that these molecules, whatever they are from Trichinella, they activate this receptor, which stimulates then a G protein.
Right.
And then the G proteins dissociate and they generate inositol triphosphate, which binds to a receptor. It releases calcium from the endoplasmic reticulum into the cytosol. These calcium ions open up a channel called TRPM5. Sodium comes into the cell, depolarizes the membrane, and that triggers the release of IL-25 from the tuft cells, which then activates these type 2 lymphocytes, which produce IL-13, and that makes the tuft cells proliferate along with the goblet cells. So isn't that amazing?
It's amazing because it's an anti-parasitic behavior, isn't it?
It is, yes.
You'd expect it to be just the opposite. Like some viral infections inhibit protein synthesis, or they inhibit the host from doing things that they can then do. This parasite just says, go ahead, kick us out, but we'll reproduce first.
They have... Well, then they're going to move to another host, right? So maybe it's part of their strategy.
It's possible.
And if, weep and sweep, but you're sweeping to a new host. So I don't think it's so bad. But these tuft cells are quite interesting.
Yes, I agree.
Are you okay with that summary?
Yeah.
Daniel, is there anything you wanted to add? I found that the tracing of the pathways was fine, but I'm not particularly enamored of describing it in detail.
No, I think you did an excellent job. I think just if our listeners have any, if you break down the different types of taste receptors, you have these G protein coupled, right? And that's your sweet and bitter. And then you have just sort of your straight ion channel ones. That's your salty, sour. And I think just the only thing I'll throw in as a summary is I think, and this is why, thanks to Trichinella, that we enjoy sweet and sour candies.
That's why you worked on it all these years. Right?
That's right. There was a researcher in NIH who decided to switch his attention to trying to block the attachment of microbes, particularly bacteria, to the cell surfaces by using the same sugar that the bacteria uses, only in a lozenge.
Right.
That you would, sort of suck on as you traveled into these high-risk areas. And the sugars would saturate the receptor sites, and therefore the, salmonella and those sorts of organisms would go right on through. I'm not sure if that ever developed into anything, but it was an interesting concept.
All right.
I'm just going to eat Sour Patch.
So maybe that's
myself.
Unknowingly, maybe that was the basis for the ability to think that this might work, because I'm sure he wasn't aware of tuft cells at the time, but maybe that's where that comes from.
So I have a book that you gave me.
Really?
By Tuft.
Oh, yeah.
I always think of him when I see tuft cells. the visual display of information.
Yeah, it's a brilliant book, actually.
You gave it to me. Or maybe I stole it from you.
No. Yeah, I gave it to you.
But Edward Tuft, right?
Yep.
You said he's not a very nice man, right?
I didn't say that. I just said that he drifted off into the world of art, but he's now back into the world that he made his reputation in, of trying to simplify complicated information into visuals.
Okay.
Which he's a genius at doing.
He has nothing to do with tuft cells.
He's a nice man. He's just, he was distracted, I would say.
Do you have a hero, Dickson?
I do. And I need to ask a question, though. Did I have this same hero at another time? Because we skipped a few pages and then went to back on track again. And did I do Sir Ronald Ross? Can we just...
Yeah.
You did.
All right. So now we're on to Carl Theodor Ernst von Siebold.
Wait, spell that. Carl
Theodor Ernst von Siebold.
How do you spell Siebold?
Siebold.
Wow.
Now,
that's quite an impressive name.
I have the feeling, yes, and he was quite an impressive parasitologist also, but I've got this sneaking suspicion that I might have also done him.
I don't think so.
Okay, fine. Well, we'll have a repeat then, if not. But I'll do that now. So it's a brief description of a man with enormous accomplishments. So it begins by his name, of course. He was an MD by training, lived from 1804 to 1885. And in everyone's view, Siebold was a generalist. That is to say, he was interested in everything. Thank you. And he contributed to such diverse fields as invertebrate taxonomy, parasite life cycles. He worked on Schistosoma hematobium in collaboration with Theodore Bilhartz. He worked on Fasciola hepatica, Echinococcus granulosus. Notice the parasite type didn't really matter to him. He got interested in all of that. And he established the journal, and I'm going to butcher this one, but I used to be good at this, Zeitschrift für wissenschaftliche Zoologie. That's not so bad. And that was his journal that he established as a result of his fascination with the invertebrate parasites of humans. And for that reason, he occupies a major place in our book.
All right. What a name. Ernst.
Lots of middle names.
And now it's time for a new case study.
Excellent.
Are we ready for that?
We're ready.
I'm
Okay.
at the edge of my chair.
All right. So I don't
fall off.
No, I won't.
Yeah. Based on Vincent's descriptions of, you're no longer being thin and long.
We don't have to continue to harp on this too much information material here. Come on, kids.
All right. So I'm always sort of struggling with which is the best case to give next, because I have like a list of sort of a backlog of cases I'm excited to share with everybody. Mm-hmm. But I saw the response here, which I really enjoyed. So I'm going to throw another one, which is a thinking case.
Oh dear.
So when I just got back from working at Floating Doctors down in Panama, and everyone's all excited to learn about parasites and see interesting things and do service and try to make a difference. But one question that always comes up is people say, so while I'm here, is there any risk? People going and doing these things, is there anything I have to worry about? And so I'm going to present a case, and this is a story of at the point that we get involved, the child is 18 months old, And the child actually had been on a medical mission for the previous year with an older sibling and the two parents. And the child has now been back in the United States for about, we'll say 2 to 3 months. And the story is right as they were leaving the remote location where they were doing their volunteer work, and this was a very rural, limited resource setting with a high load of all the wonderful things that we like to discuss. And so right as they were leaving, they were giving their dose of albendazole. They felt quite good about that. And the call comes to the mom. For some reason, they call the mom instead of the dad. I'm not sure why that is. And it is that this 18-month-old is at the child care and has passed something. And I actually get to see the video of this, which, of course, I enjoy. And it is, we'll say, something serpiginous. It's, we'll say, 5 or 6 inches. I'm going to use inches. So it's pretty big in length. It's not moving a lot, but it actually is moving a little bit. And the people at the childcare would like the child to be picked up.
Indeed.
Now, this came after the dose of albendazole. Is that correct?
Yep. It was 2 or 3 months afterwards. So
2 or 3 months.
Yeah. So there's sort of a question, like, what is going on here? Like, does this make any sense? I mean, the child took their dose of albendazole, and doesn't this treat all kinds of things? What could this child possibly have? And what should we do?
Dickson has it.
Well, he thinks he has it, but I need some more physical description of the object, which, if you did, would give it away, I'm afraid.
Okay.
Now, this 18-month-old child.
I will throw in a few things because I think this is important. This will be helpful for us. This object it's not flat; it is round.
Oh, that's a big hint.
And I think that's a helpful hint.
Color?
I'm not going to give you the color.
Okay.
Now, this child, 18 months old, living in this remote location, is crawling around in the dirt. Is that correct? Exactly.
Yep. On the ground, playing with a lot of the local kids.
And there's dirt on the floor of the home, I guess, right?
All the different places. This is actually the parents are going to these remote locations, so it's mobile clinics around. And
they're both physicians.
They move around. Huh?
Actually, one is medically trained, so one is a provider, and the other works in sort of support and logistics on the missions.
Got it.
And during the day when they're working, where is the child?
Usually playing with the kids in the local villages.
This remind me, an 18-month-old. This is walking, right?
This is even smaller than that one.
Actually, probably been walking for the last 6 months. I think this child started walking, a little less than a year, right about a year. So they've been walking.
Okay. Walking around, playing in the dirt, playing in the water, probably, right? From time to time, putting things in his mouth.
Yes.
And when it's time to eat, what do they eat?
So I give too much of the diet, people guess which part of the world, and I want this to be open because this is sort of a case that could, but usually the breakfasts are fried dough, and then the afternoon meal tends to be a rice and beans.
Sounds good.
Wait a minute.
Sounds really good.
That's right.
All right. And
no apparent illness.
Yes, no apparent illnesses, right?
Well, the child's fine. The mom's fine. It's the caregiver at the.
What about the other child?
Most upset. The other child has no complaints. Everyone's feeling well.
And no events that were contiguous with the ingestion of albendazole in any of the others. You said they felt pretty good about that. What do you mean they felt pretty good about that? That means
they took the child. Actually, everybody took their dose of albendazole before departing this location, and they felt pretty good. Like, okay, now we've taken care of that. We don't need to worry that something might come out of the.
And how long was the mission? A year?
They've been there for a year. So sort of the prior, so from the child being 6 months old until, we'll say, 16 or 4 months to 16.
Yeah. All right.
Something like that.
So in 1950, roughly, my father came from Italy. he was a doctor, and he came to do an internship, as I mentioned, I think on TWiP, and he was in his new hospital, and for some reason he took an anti-parasitic drug. I don't know what it was, and he said he passed a very long tapeworm. Very, very long.
Isn't that interesting?
From Italy.
Wow. No, well, it's not uncommon.
Now, I don't, since he's no longer around, I can't query him. Or we could have him on the show,
We had probably two choices for that one, either Taenia saginata or Taenia solium.
Mm-hmm.
Both prevalent throughout Europe.
And what drug would he have taken that would immediately kill the worm?
Probably Adabrin. Adabrin is that was an old drug that they used to give the troops during the Second World War for malaria. It also treats Giardia. It also treats tapeworm.
They don't use it anymore?
No, it's too toxic, I think.
It was a neurotoxicity was the issue with Adabrin?
Yeah, something like that. And you know what they used to do? They used to check for Giardia in your stool to see if you were taking your Adabrin. Because if you weren't taking your Adabrin and you caught malaria, you were placing everybody else at risk.
Interesting.
So, yeah.
Giardians of the galaxy.
Hey. That's right. I insist.
Insist, said the amoeba.
That's right. And Giardia insists.
All right. Well, let me read one or two emails, then we'll quit. But this is a good one from Anthony. Is the diarrhea associated with Giardia all due to the malabsorption of fat? If so, would an infection in a vegan on a low-fat diet be asymptomatic?
Interesting question.
You know, it is an interesting question, and just to sort of think it through. So we do describe it as a fat malabsorption diarrhea, but it's not just. It actually you get a loss of the villi, and you get a loss of the terminal enzymes.
Yeah, it fuses.
So so one of the things we have to tell people is, you know, I made this mistake. I had a severe case of Giardia myself at one time, and when I felt better, what did I do? I went out and I had enchiladas with melted cheese all over it. And, I did not make it back to the car. And so you also develop a lactose intolerance, and so it's not just fats. But I would actually assume that, and this is true, if you tell people to go on a bland, low-fat diet, it does greatly improve symptoms. So it wouldn't be asymptomatic, I wouldn't say, but it helps. And then once you do treat a person, you know, they have to be off alcohol for a week, unless they're Irish or like me. But then they gradually ease themselves into a diet and eat, gradually introducing more fats and gradually introducing dairy as well.
All right.
Dickson, can you take the next one, please? We do.
Charlotte
yes,
writes,
please.
Remote location, dear Twipsters. Thank you for keeping me entertained whilst on my sickbed. 4 months later, still recovering from a collapsed disc L5 and separated from reaching my scientific dreams, PhD and beyond. But you've raised a smile from me. Charlotte. London. That's a rough one. L5 is a tough one.
Daniel, can you take the last one, please?
Anthony writes, some years ago, I did tech support. One user insisted on being present when I worked on their computer. We arranged for a 4 p.m. appointment. On arriving, I was asked, how long is this going to take? I have to go home. By the look on their face, the person appeared to be in some sort of distress. What's the matter? I have to go to the bathroom. But the men's room is just down the hall. I don't use public restrooms. Flushing the toilet sends a fine spray of feces onto the seat.
Oh, dear.
I remembered this when hearing the remarks on TWiP 167 about fecal oral transmission. Was feces actually aerosolized by flushing? Indeed, there is a toilet plume. He gives a reference there. Pervasive and invisible contamination is possible. That says TWiP 168 email. And actually, you know, there is the well-described toilet plume that does contain minute fecal particles. I just throw that in.
Yeah, this is a review article. Lifting the lid on toilet plume aerosol, a literature review. That's a good title. But, you know, the SARS outbreak, when it reached the Metropole Hotel in Hong Kong, was thought to have accelerated its spread by, they had bad toilet plumbing, and they actually traced the epidemic through the toilet plumbing, making aerosols. You know, it's really, you have to be careful. Yeah.
But remember, this is your own feces.
Well, but
the toilet doesn't have feces in it already when you sit down,
there's always
right?
a little bit of feces in it.
And there's always a feces film on that area where you can sit, right? A film of feces, a thin film of feces covering the entire planet.
So
That's
I can give you a better quote for that one, but
That's okay.
Robert Shope Sr. had a wonderful quote that we don't want to quote that here. We're too dignified a show for this, but
Dignified.
Yeah, we have our standards to maintain here.
This is TWiP 168. You can find it on any podcast player which you use on your phone or tablet. We only ask, besides you enjoying, to subscribe so that we can tell how many people are listening. Now, if you would like to see the show notes, in particular the letters, you go to microbe.tv/TWiP, and there we have references and links, but more importantly, the letters from everyone, including the really long ones that we don't read all of. So you should check that out. And of course, if you really like what we do, you should give us a little money. Give us your money. You can give us $1 a month. That's really not much. It's less than a cup of coffee here in the continental U.S. And I don't know where you can get a cup of coffee for less than $1, right?
Not even in your own house.
When I was in college,
Yeah.
At Cornell University in Ithaca from 1970
Careful.
to 74, you could buy a beer for 25 cents
That's right.
at the local bars.
But a quarter was worth something then,
Anyway, $1 a month. You can go to microbe.tv/contribute, and you can use Patreon or PayPal to do that. And, you think, what's $1 a month? Well, we have lots of listeners.
It adds up.
It all adds up. We have expenses, and there are things we'd like to do. Yeah. Questions, comments, case, guesses, TWiP at microbe.tv. Daniel Griffin's at Columbia University Irving Medical Center and parasiteswithoutborders.com. Thank you, Daniel.
Pleasure as always.
It is at that website where you can find the PDF of parasitic diseases.
Indeed.
6 and soon 7.
That's right.
Amazing. And then 8.
7 is in the oven.
And then 9.
It's cooking.
Dickson Despommier is at trichinella.org and thelivingriver.org, and also many other websites. Thank you, Dickson.
I had a great time.
There is someone on Twitter called the fake Despommier,
I know.
It's even got your picture.
I can't account for that.
But he's not disrespectful. He's highly respectful of you.
Didn't authorize it. That's the unauthorized Despommier Twitter.
I'm Vincent
I don't tweet.
Racaniello. You can find me at virology.ws. Music on TWiP, as you heard earlier, is composed and performed by Ronald Jenkins. You can find his work at ronaldjenkins.com. I'd like to thank ASM for their support of TWiP. You've been listening to This Week in Parasitism. Thanks for joining us. We'll be back soon. Another TWiP
is parasitic.